So now let's use this binomial coefficient, what we know how to do, and finish this binomial distribution. The binomial distribution just shows all the outcomes and their probabilities, just like a normal probability model. So use the formula to calculate the probability of x being 4 and show the binomial distribution of the random variable x. So we've already done a probability of having exactly 1, 2, 3. Actually, I don't know if we've done 3 yet, but we're about to. Now we want to do 4, and then we'll also have to do the probability of there being 5 as well, and that will complete the binomial distribution. So to calculate the probability of there being 4 children, exactly 4 children who have type O blood type, we're going to do the binomial coefficient, 5 choose 4, times the probability of 4 successes, so 0.25 to the 4th power. That means there'll be 1 failure, 0.75 to the 1st power. Let's open up the calculator and figure out the binomial coefficient of 5 choose 4. So on the calculator, I will hit 5, and then go to math, probability, NCR, choose 4. And so there are 5 different ways I could have exactly 4 children of type O blood type. So I'll copy that to the notes. So the binomial coefficient is 5. So now I've converted this to 5, and now I can do my multiplication. I'll get 0.0146. So there's a 0.0146 probability of getting exactly 4 children with type O blood type. I want to show you one other way to calculate binomial probabilities, and this is the easiest way. This is the best way that you should do it for every problem that you come across, and I have on the bottom of the notes the formula for how to do this. So if you look here in the calculator, I'll show you where this is in a second. You can do Binomial Pdf for number of trials, probability of success, and the number of successes. This will calculate the probability of x being whatever value you put into your calculator. So this is going to show you x that's exactly equal to. So for example, I'm about to use this for finding the probability of x being equal to 4, exactly equal to 4. But I've got a couple other problems that we're going to do in a second where this will compute CDF instead of PDF will compute the probability of x being less than or equal to some number. So as of now, I want to use PDF to find the probability of exactly x being equal to exactly 4. And then in the future, I'm going to look at calculating intervals. So in my calculator, I'm going to write my statement out, and then I'll open up the calculator and show you how to find it. So the best way to answer this question is to do Binomial Pdf. 5 is the number of trials, probability of success is 0.25, and x is the number of successes 4. So let's open up the calculator and see if this gives us the same value. So in the calculator, it's going to be a binomial distribution. So I'll go to second vars, takes me to distribution. So you can see we've been using normal CDF. Now we're going to use binomial PDF, which is exactly equal to. And so it's going to give me the wizard where it's going to ask, what's your number of trials? 5, probability of a success was 0.25. And the x value, number of successes, we said was 4. So if you don't have the wizard, it won't take you to this screen. It will take you to the next screen. And this is what you need to type in. It'll copy the binomial PDF statement. You need to put 5, 0.25, 4. And then you can hit enter, and it will give us 0.0146. And so you can see this gives us the same answer for our calculations. And this way is obviously going to be the best way to calculate binomial probabilities. So now we have 1 through 4. We need to figure out what's the probability of them having 0, and we need to figure out the probability of them having 5 with type O blood type. So before we do that, let's just jump back up and double check these first 2 questions. What's the probability that they have exactly 1 of the 5 children that is type O blood type? We could do Binomial Pdf where we're looking for 1 instead of 4. And for this problem here, we could do the probability of exactly 2. So we look for Binomial Pdf NPX where x is 2. And I'll write out these 2 statements so you can see how you could have done these using the Binomial Pdf function in the calculator, which is the best way. Okay, so here are the calculator statements. Set number of trials is 5, probability of success, and 1 for this statement, 1 success, and 2 successes here. Let's open up the calculator and see if we get these same 2 values. So you can see I've got the same probabilities using the calculator. So let's scroll down to where we left off, and we're going to write out the binomial distribution for this random variable x. So I've written out the binomial distribution here because I want you to realize that a binomial random variable is just a random variable that has a normal, it's like a normal probability distribution, but it meets the conditions of being binomial. So you can list all the outcomes and their probabilities, which means all of these in the sample space, they should all add up to 1, just like normal. And we can answer these next questions since we've already calculated all the probabilities. We could answer these next questions like we've been doing all year, where we find the probability of x being less than or equal to 2, where we would add these 3 probabilities together. But generally, they're not going to give you a table that has the probability distributions. So what I want to do is I want to show you in your calculator how to find these probabilities using the binomial CDF, the cumulative function, because this is now an interval. PDF gives you exactly equal to 2, but this is saying 2 or less than. So before I jump into the calculator, I do want to show you, this is the last time I'll write all this out. I'm going to write this out using the formula for binomial probabilities that we've been using before. So I'm going to write out the probability of x being 0, which if x is 0, then there's no successes. So it's going to be 0.75 to the 5th power because that was 5 failures. I'm going to write out these 2 probabilities, and then this will be the last time I'm going to show you how to do it in the calculator. So let's run through this. 0 successes is 0.75 to the 5th, there are 5 failures. 1 success means 5, choose 1, the binomial coefficient. So we can calculate what that is. Actually, we already have done it. I believe it is 5, I can't remember. 4, I think. Well, it doesn't matter. But if there is 1 success, that means 0.25 to the 1st power, 0.75 to the 4th power, 4 failures, 1 success. 5 choose 2 has a different binomial coefficient, 2 successes, so 0.25 to the 2nd power, and 3 failures, so 0.75 to the 3rd power. If I were to punch this in the calculator, I would get 0.8965. But I remembered I didn't need to punch it in because I had my table right here. So we've already calculated each of these probabilities earlier in the notes. So I had 0.2373 is where I got this, probability of 0 plus the probability of 1 plus the probability of 2 to get 0.8965. Now, the easiest way to do this, like I've said, is to throw this in the calculator using binomial CDF because it is an interval instead of exactly equal to. So I'll write out my calculator statement here and then show you how to do it in your calculator. So here's the statement I'm going to put in the calculator, but you need to remember that whatever value you put in here for x, the calculator is going to give you less than or equal to this number. So in this case, it's easy because x is less than or equal to 2, so I know to put it in 2, but it's not always a less than or equal to, like we'll see in the next problem. So let's pull up the calculator here. So in my calculator, I'm going to second vars to get to distributions. Now I'll find binomial CDF. Number of trials was 5. Success is 0.25. And then the value I want to find is less than or equal to 2. So I put in 2 here. It will paste this. You can see CDF instead of PDF. So I get the probability of 0.8965, which should sound familiar. So you can see 0.8965 gave me the same probability as before. So now let's calculate the probability of finding there being less than 5. Notice it's not equal to, but my calculator can only do equal to statements. So I need to first write out an equal to statement that is the same as this here that they've asked me to find. The probability of x being less than 5, it's the same as saying the probability of x being less than or equal to 4, because if it's less than 5, then it's 4, 3, 2, 1, or 0. So this is a statement I'm going to need to put into my calculator. So I'd put this in my calculator, binomial CDF, 5.25, and x, the number of successes is 4 or less, and it would give me a probability of 0.999, which you can also look up here. You could have just subtracted this value because it's the complement rule, right? So last one, the probability of x being greater than 3. So we need to write this. Remember, my calculator will only tell me what is less than or equal to. So I need to rewrite this as a less than or equal to statement. And since it's asking for greater than, my calculator only gives less than, I'm going to have to use the complement or a complement statement to figure out this probability. So to find the probability of x being greater than 3, I have to use the complement rule because my calculator can only tell me that which is less than or equal to. So my calculator can tell me the complement of this, which would be 3 or less, because if it's greater than 3, it's going to be 4 or 5. But I want the complement of that, which would be 3, 2, 1, or 0. So that's why I'm doing 1 minus its complement. And this is what I'll put in the calculator to get the correct statement. So I'll open up the calculator and throw this in to show you what the correct answer is. So for my notes, I have 1 minus, I need to go to my distributions, binomial CDF, number of trials is 5.25, and I'm looking for 3 or less than. So 1 minus that will give me 0.0156. So I've copied the probability from the calculator, 0.0156. And if you get confused about how to do this complement statement, well, we can just go up to the table and double check our answer here. So let's go up and see what's the probability of being greater than 3. So it'd be 0.0146 plus 0.001, which is 0.0156, like we saw. So we put our calculator statement in correctly. So just again, there's a reminder here for how to calculate or how to do these calculations on the calculator. Remember, CDF is less than or equal to, and PDF is exactly equal to. The next video will use what we've learned here to calculate binomial probabilities.